I thought I'd do a little bit of development on the Arduino, which I'd never really thought about before. I thought what I'd do is I'll use a Raspberry Pi, and on the Raspberry Pi I'll develop using the Arduino tools and upload to an Arduino and do some development. So I thought I'll use my Raspberry Pi here. It's connected via a network cable to my laptop, so I can do screen grabbing, but it could just plug in a display on that. I've got a little Arduino here, which is called the Pro Mini, but Arduino on their website say they don't really support this particular device anymore, but it's no different to any other device really. And to program it, I've got this thing called an FTDI chip, which is just like RS-232 chip really, but it has the connector pins which are laid out in the same way that these pins are laid out on the Arduino. And then of course you need a USB cable to connect the USB port on the Raspberry Pi to this RS-232 adapter, but this one's got like a mini USB connector on the end, so you need to make sure whatever device you've got, which is an FTI device or however you program it, you can program these in many different ways. This one doesn't have a USB port on it, but some of these Arduino boards have USB ports which you can just plug straight into. So I'll start just by connecting up the USB port. You've got to be careful on which way around you connect these because it's not polarized. So you can see the labels on it: ground, VCC, RX, TX, and so you need to make sure that you get a ground. And the CTS on this is the same as ground. Well, it is on the Arduino board, so that's fine that they're both ground. Then make sure that the VCC is 5 volts, RX goes to TX, and TX goes to RX because it's just RS-232. So it connects like this. I've put all my pins on the bottom. When I've got this board, you get the pins separately, and you can just like put them whichever way around you want. And then if I plug in the USB mini cable, and then plug that into the Raspberry Pi, and you see that it powers up. And by default, when you buy these Arduinos, they seem to tend to have a flashing LED program. So this LED on the Arduino board just verifies that it's running because it's running the default program on the board, just to flash the LED. So to install the Arduino software on the Raspberry Pi, first open up a command window. Now the Raspberry Pi I've got here, I've just installed the default Raspbian image, which doesn't have the additional packages on it. It's just a Raspbian Desktop without additional packages. Now if I go to the desktop, because that's why I've downloaded the Arduino software. But first of all, do a sudo apt-get update first, just to make sure all the packages are up to date. Now I'm going to get some errors because I'm not connected online at the minute, so it won't like that. And then do a sudo apt-get upgrade, and that just makes sure all the packages are up to date from the install of the image, just to minimize any issues. And then because I did the basic desktop, now I'm not sure if you get a Java runtime environment on other installs of Raspbian, but it's worth just doing a apt-get install. You need to do sudo install, and then it's default JRE, because you need the Java runtime environment for the Arduino software, and it's already installed the mine, so it should say it's already the latest version. Then you need to go to the Arduino website and download the Arduino IDE, but you need to download it for the ARM environment, and they provide two different ones, the ARM32 and ARM 64-bit environments. Now I'm using it on the Raspberry Pi B, and I'm using the ARM32 one. So if I just list what documents I've got here. So this is the one which I downloaded, Linux ARM, and it's the 32-bit one, and the current version is 1.8.10. But there's also a 64-bit version. Now the new Raspberry Pi, which has the dual desktop and everything, that might be a 64-bit device. But try one of them, and if it complains that it can't run commands, then try the other one. But the 32-bit one works on the Raspberry Pi Model B. The B Plus, I'm not sure, probably the same. But to install it, all you have to do is do tar -xf, and then the name of the actual archive. Now I've already unzipped it here, but if you hit return on that, that'll unpack it into this directory Arduino. And then if you go into the Arduino directory and see what's in there, all you need to do is run the install program, which is install.sh, but do it as sudo. Now again, I've done this, but that will take a couple of minutes, and it will just say that it's done the installation. But after that's done the installation, if you, on the top left hand corner, the Raspberry Pi icon, and then in the programming section, you should see this Arduino IDE icon appear. And if you click on that, it'll open the Arduino IDE. It takes a few seconds just to go through the initializing packages thing. And then it'll come up with the actual IDE environment itself. And this is the same as you would get on Windows, because they've written it in Java. It should look and feel the same, exactly the same, no matter what platform you use it on. So on the Raspberry Pi, it should operate and look the same. And so here it is open. Now, the first thing you need to do is set up a few things in the Tools menu. So telling it what you've got. So I've got the Pro Mini. So you need to select that from this list. It's on the right hand side here, so I've selected the right device for mine, and then you select the processor which is on the board. Well, the board that I'm using at the minute is the 3.3 volt 8 megahertz one, and then you need to select the device on which your FTDI chip is connected to, and by default it should be easy to see because it should be the USB one, so there shouldn't be any, unless you've got another board plugged into USB, it shouldn't be confusing. It just select the dev TTY USB, and it's probably USB 0 that you'll have. Now the programmer also you need to select. Now you can actually select AVR ISP for this FTDI board. Now depending on the type of connection you've got, you might have to select a different thing here. But because it's AVR, which is the microchip thing, and not Arduino ISP as an ISP, although Arduino ISP. Although I've used Arduino ISP and that works, but if you use AVR ISP, because it's the chip is AVR, I believe that it means you don't actually use the bootloader on the chip, so you probably don't need to have a bootloader on there. By default, these boards come with a bootloader on them, so it doesn't matter. But in a later video, I'm going to see if I can prove that actually you don't need a bootloader to actually program it this way, although I don't know yet. So I've got the Arduino board here still, and it's still flashing an LED, and I'm going to use the IDE up here, and this is just the program which does the flashing of the LED, and I'll comment out. It's written in C, which is or C++, which is a good language to write stuff in, and all I'm going to do is I'm going to comment out where it actually switches on and off the LED, and save that and do an upload of that just so that the LED stops flashing to prove that it's uploading the sketch. Now you can do just compile the sketch with this tick mark, or an upload as well, compile and upload. So I'll click on the compile and upload, and here it shows the description of compiling. It just shows you the status of the progress. So it compiles first, and it goes into uploading, and it gives you like a summary of how much memory you've used and how much memory you've got. And it says when it's finished uploading. And so now if we look at the board, the LED actually stopped flashing on the board now. So it's showing that it's actually uploaded the new code. But if I now just undo those changes and put the flashing LED back in, Control S to save, and then upload the sketch again, and then that should start flashing again once that's compiled and uploaded. So there it is flashing again. But also on these, the thing about the Arduino is it programs down a serial link, and this serial link can be used for debugging as well. So in your sketch, you can put like initialization of the serial port, and then you can send data back down the serial port. And if you look under the tools, I think it's the tools menu. Serial monitor, and if you open up that, and then you get the debug messages coming back. So everything works as normal on the Raspberry Pi for developing on Arduino, and this is how I'm going to sort of do some development in the future on Arduino.